Welcome to GWA Physics. Today I wanted to talk a little bit about how to solve inclined plane problems that we had on our simple machines. First of all, here if you look at the picture you can see that we've got a barrel, and let's say that the barrel was 250 newtons, and that barrel had to be lifted onto a loading dock which was 2 meters tall. So if we were just going to do the regular work that was going to be done on the barrel, then the work out would be equal to the force of the barrel times the distance that the barrel had to move. And we could see, I change markers here right quick, you could see that the weight of the barrel was 250 newtons, and that the distance was going to have to be 2 meters, and so that the work done would have been 500 newton meters of work. But if we use the inclined plane instead, then it shows that we could probably push the barrel or roll the barrel up the inclined plane with a force that is smaller than the force necessary to lift the 250 newton barrel off the ground and up onto the loading dock. And the way that we do that is that we solve for the mechanical advantage of the inclined plane. Well, one of the things that you notice that's missing here is that we do not know the length of the inclined plane, but we do know that the angle is 20 degrees, and we know that the opposite side is 2. So using the sine function says that the sine of the angle over 1 is equal to the opposite over the hypotenuse. Then we substitute our values in, and we have the sine of a 20 over 1 is equal to 2 over, and I'm going to use the letter h for hypotenuse. And so right off we need the sine of a 20, which is 0.342, and you can see that we're going to need to cross multiply, so 0.342h is going to be equal to 2 times 1, which is 2. And the next function that you see here is that we're going to have to divide. So 2 divided by 0.342 is the height of the hypotenuse of the triangle is going to be 5.85, and that would be meters. So now we know that we're going to have to roll that barrel up the inclined plane 5.85 meters. It's a longer distance, but it should be a lesser force. Now, the mechanical advantage for an inclined plane is the hypotenuse divided by the opposite side. So we have 5.85 divided by 2, and that's going to give us a mechanical advantage of 2.92. So it should be 2.92 times easier than if we had to just lift the barrel by itself. So right away, if we have a 250 newton barrel, 250 newtons divided by 2.92 will show us that we're only going to have to push the barrel with a force of 85.6 newtons, which is less. Now, a lesser force over a longer distance. Now, let's multiply these together right quick. The work in is going to be equal to the force that we apply times the distance that we're going to apply it. Well, we're going to only have to apply a force of 85.6, but we're going to have to do that over a distance of 5.85. Well, when we multiply those together, 85.6 times 5.85, we get 500 0.76 Newton meters. Now that's a little bit more than what it would be if we lifted it like that, but I believe that this is due to rounding, and you can see that the work in is approximately the same as the workout. If you have any questions, contact me about it, but thank you for watching the video.